Hi, everyone, and welcome to another episode of the Global AI Notes. Today, we hear from Prerna Singh, who is a senior applied scientist in the industry AI group at Microsoft. And she's going to help us to choose between RAG and GraphRag, RAG being Retrieval Augmented Generation. Hi, welcome, Prerna. Good to see you. How are you?
Hi, I'm good. Thank you. Thank you, Roland.
For the people who don't
How
know
are
you
you?
yet, could you please introduce yourself?
Sure. As Roland mentioned, I'm Prerna. I'm a senior applied scientist at Microsoft in Redmond. I'm currently a part of the industry AI group, where I develop machine learning solutions for different industry verticals like finance, retail, and sustainability. Prior to Industry AI Group, I was a part of the Bing Search team where we develop machine learning models to understand the data on the web. And prior to that, I was a master's student at Carnegie Mellon University. So, yes, I'm excited to be here and I'm excited to talk on the topic of RAG and RAG versus GraphRag. So, looking forward to interacting with the audience here.
Well, very much looking forward to learn because you are actually using AI to add value for multiple industries. So a lot to learn there. Um, are you ready? Are you ready to share your screen? Because we had some technical difficulties leading up. So let's try again.
Yeah, sure. Let me give it a try. Are you able to see it, Roland?
Yes, it's coming true and it's perfect. Yeah. So good luck. The stage
Uh,
is yours.
mhm.
And we'll do for the
Yeah.
people who are viewing this live, we'll do the questions. So post them in the chat. We can do them during, and we have a Q&A after. So the stage is yours.
Sure. Just one moment before that, Roland, could you check if I'm switching slides? You can see the slides moving because I'm using two screens, so I'm not sure.
Of course. Yeah. So now seeing title slide.
Yeah, let me go ahead and move to the next slide. Okay, it's not letting me switch, I guess. Can you see the next
There it
slide
is.
now?
Yes, that's the next slide.
Okay. That
Yeah,
means it's
working
working.
perfect.
Okay, then maybe we can get started. Thank you. Okay, so today I will be giving a talk on RAG versus GraphRag. So let's start by looking at the agenda for today's presentation. So we will begin with a brief overview of the retrieval augmented generation or RAG systems. We look at the challenges associated with traditional RAG approaches. And next, I'll provide an overview of the graph-based RAG methods and present an in-depth discussion on two specific graph-based RAG approaches, that is Raptor and Microsoft's GraphRag. And finally, we'll conclude with practical considerations for selecting between these algorithms. So with that, let's get started. So on this slide, I present a flow diagram illustrating a basic RAG pipeline. So it is composed of basically two parts. The red dashed line here indicates the two phases in a RAG pipeline. Everything on the left of this line falls under the indexing phase, and everything to the right falls under the query phase. So in the indexing phase, given a corpus of documents, we divide those documents into smaller chunks. It's called chunking, and people use different strategies for it. Now, each chunk's text data is then processed. We create embeddings for those chunks, and then an index is built on top of those. Sorry, and then an index is basically built on those chunked data. Now, the next phase is the query phase. In this phase, given a user query, top k relevant documents from the index are retrieved. Now, you can use different strategies. BM25, vector search, hybrid search are some of the popular retrieval techniques which are used. And once those top K or let's say 5 documents are retrieved for the given query, like the most relevant documents, they're passed into a large language model along with the query to generate an answer. So, this is how the query phase works. Now, building a RAG pipeline has become super simple with Microsoft Azure. Azure offers the feature where user can bring their own data and create RAG pipelines on Azure. This feature leverages Azure AI's document intelligence to ingest text data from different document types, such as PDF, even images, PowerPoint presentations, and Word documents, to name a few. It then uses Azure Search to create an index and Azure OpenAI services to generate an answer based on the retrieved context. Now, to learn more about the process, you can refer to the resources linked here after the presentation. I will be sharing the presentation and the resources after the talk. So feel free to check out those. So traditional RAG methods work really well on extractive questions, where the answer to a given question lies within a single chunk. For example, here the question is, what is in front of Notre Dame's main building? Now, to answer this question, as long as this corresponding chunk is retrieved, the LLM should be able to reach the answer. And the RAG systems usually find it pretty easy to retrieve and answer such questions, which are extractive in nature. However, most RAG methods struggle to answer complex questions. Most RAG approaches do not perform well on multi-hop questions, which require connecting different parts of text. For example, here the question is, in what year was the creator of the current arrangement of the Simpsons theme born? Now, in order to answer the question, the system needs to retrieve this S1 chunk, which mentions that the creator of the current arrangement of Simpsons theme is Alf Clausen. And it also requires this S2 chunk, which mentions the date of birth of Alf Clausen. It needs to understand these two separate chunks, connect the information in order to reach the correct answer. So most RAG approaches do not perform well on such multi-hop questions, which require connecting different parts of text. The second question on the slide is another example which requires us to compare, the nationality of Scott Derrickson and Edward in order to reach the correct answer. Additionally, most RAG methods are usually unable to answer theme-based questions that require complete understanding of the overall document or corpus. For example, let's say I have a Cinderella story as the input document. I create chunks, let's say I perform paragraph-wise chunking and build a RAG system on that Cinderella story. And if I ask a question like, how did Cinderella reach her happy ending? Or another question could be, what is the central theme in the document? Now, in order to answer this question, the RAG system needs to understand the overall central theme of the document. So, in case of traditional RAG system, the retrieved top 3 or 5 paragraphs or chunks may not contain enough context to answer such questions. So, graph-based RAG methods provide solution to these problems. Graph-based RAG are capable of handling both extractive questions, which require specific information retrieval, and high-level questions, which involve synthesizing information across a document. Graphs are used to present the information within the documents. Now, the aim of graph-based methods is to effectively connect different parts of the document, enabling a more comprehensive understanding. Now, going forward in the presentation, we'll focus on 2 popular graph-based RAG methods. The first one would be Raptor, which uses a tree structure to represent the documents in a corpus. And the second would be Microsoft's Graph RAG, which creates an entity-based graph on the corpus. So RAPTOR stands for Recursive Abstractive Processing for Tree Organized Retrieval. The main idea here is to create a tree-based retrieval system which captures both high-level and low-level details in the document. Now let's look at how Raptor works. So just like any RAG approach, this too has two phases. One is the tree creation phase or the index creation phase. And the second part is the retrieval phase or the querying phase. So given a corpus or a large document, we want to create a tree representation of the document. That's our first step. And the second step is once the tree is created, at query time, we want to retrieve the most relevant nodes from the tree with respect to a given user query. So let's see how the tree creation part of the algorithm works. Here are the steps of the algorithm. So given a corpus, the first step involves chunking similar to a traditional RAG approach. In the second step, we generate vector embeddings for these chunks. Now the chunks and their corresponding vector embeddings, they form the leaf nodes of the tree. In step 3, similar chunks are grouped together using clustering, as shown in the middle image here. So for example, let's say node 1, 2, 3, 4, 5 over here are the leaf nodes. So they are basically the raw text that we took from the documents after chunking. These correspond to the chunks that we created. In step 2, we perform clustering. So the algorithm used here is Gaussian mixture model with soft clustering. So all the nodes which are similar in some form, let's say if the documents are about retail and let's say related to fashion, and we say that the node 1 and 3 talk about Nordstorm, for example, or let's say they talk about Macy's. So these are similar in some way and they will fall under the same cluster. So once we perform clustering on this level, on the lower level of nodes, once the clusters are generated, then the next step after that is to summarize all the nodes that fall within the same cluster. So summaries are generated for node 3 and 5, the data in 3 and 5, and a new node is created, which in this case is 6. It's called the parent node. So this step is done for all the clusters that were generated. And after that, the process repeats. Once we have the parent nodes, then we generate their embeddings. Then we go ahead and perform clustering again. And we keep doing these steps until it's no longer possible to create clusters at a level. So this is how the tree creation works. Now, once we have represented our data in form of a tree structure, a raptor tree is created, the next step is to look at the retrieval part. So for this purpose, the authors in the paper propose two distinct strategies, as shown on the slide here. So the first strategy is the tree traversal method, where the tree is traversed layer by layer and the most relevant nodes at each level are selected based on cosine similarity between the query and the nodes. The second approach that the authors propose for retrieval is the collapsed tree retrieval. And as indicated by the name, the tree is collapsed into a single layer in this method, and then cosine similarity between the query and every node in the flattened tree is compared, and top k nodes with the highest similarity scores are returned. So Raptor is able to answer theme-based questions and can connect different parts of the document. For example, here Raptor successfully answers a high-level question about the Cinderella story. The example shows the comparison with DPR, which stands for dense passage retrieval, which in simple terms could be considered similar to embedding-based search. But in conclusion, overall, Raptor method builds a tree-based structure on the corpus. It leverages summary nodes to get a more comprehensive understanding of the corpus. So I think this is a good time where I would like to pause and see if there are questions up to this point in the presentation.
No questions yet from the audience, but I do have a question myself. Is this clustering mechanism, is that similar to how attention heads work?
No, this is this is different in the sense this is basically a simple clustering algorithm like Gaussian mixture model, and I think it's flexible in the sense that uh, people can use a different they can use a different algorithm as well, like k-means clustering, for example. So I think there's some amount of flexibility there in terms of the algorithm.
Okay, that's clear. If the audience has any questions, post them in the chat. I will ask them later on.
Sure. Thank you. So with that, the next algorithm that we look at is Microsoft's graph rag. So this technique was basically proposed by Microsoft's research team and it became open source in the summer of last year. So this RAG method, basically this graph-based RAG method, builds on a more granular. They basically build a more granular level graph as compared to Raptor, because in case of Raptor, as we saw that the leaf nodes are basically the chunks themselves, and they can consist of couple of sentences, or even an entire page, for example, depending on what the chunking strategy is. But Microsoft's graph rag builds a graph on a more granular level. Basically, it does entity-based graph. So given a text, it extracts different entities from it, like name of a person, organization, and uses those entities, and then uses relationships between them as edges in the graph. So this is a more granular graph, as I mentioned. Let's look at the algorithm in detail to understand more about how this works. So GraphRag is a structural hierarchical approach to RAG. And similar to traditional RAG pipeline, GraphRag consists of an indexing phase and a query phase. Now, the first part is graph creation or the indexing phase, which corresponds to the pipeline shown on the left here. The first step, just like any RAG algorithm, is to chunk the documents. And then in this case, LLMs are used to extract entities, and entities can be name of a person, organization. And also in their, since it's open source, we have the flexibility to modify the prompt and change the entity, the prompts, depending on the use case that we are working on. So LLMs are used to extract the entities and their corresponding descriptions. The next step is relationships consisting of source, target, and description are extracted using LLM for every chunk. So basically, given one entity as the source, another entity as the target, relationship between them could be anything that connects those two entities, like this person is the father of this person. So the father of could be corresponding to the relationship, and whereas the person name of the person one and the person two could be the entities respectively. So after that, once the relationships, the extracted entity nodes, relationship edges, and claims constitute the knowledge graph. Now, once the graph is generated, a community detection algorithm is run. Yeah, so here the community detection algorithm, which GraphRack uses, is called a Leiden algorithm, which provides a hierarchical community structure on top of the graph. So basically, they have three levels of communities. One is the root level, C0, a high level, C1, and then a global, which corresponds to C3. And then a merging is conducted on top of those on top of those communities to generate community level summaries. Now, moving on to the query time, given a user query, relevant community summaries are retrieved, which are then used to generate partial responses, which are combined together to form the final response. So given a user query, we first extract the list of most relevant summaries, and then we use them to generate partial responses. And then we do something like map reduce, or a strategy to combine those partial responses into a final answer. Now,
GraphRag offers an accelerator, which is an easy way to build a GraphRag pipeline. The accelerator
Yes, so the accelerator basically uses multiple Azure services. So as you can see, I would recommend that the easiest way to build a graph rag is to use this accelerator package, which is available in the open source repo. So what they do is, once we build this graph rag, I'm sorry. So basically, once we use this accelerator, it basically provides us an API link. So what we can do is we can take our data, basically the corpus, put it into a folder, and then make API calls to, first upload the data. Then we can create a graph. We can check the status of graph creation. And once the graph creation is successful, it also has these methods which allow us to query the graph, retrieve the relevant context, and then send it into another large language model to generate the answer provided the query and the context. So this is the easiest way to onboard to GraphRag, and this basically connects different Azure features. For example, it uses the blob storage. Internally, it uses Azure AI Search and Azure Open AI services as well. So yeah, this is one of the easiest way. And once we onboard to it, get comfortable with it, later on we can dig deeper into the actual GitHub repository, which allows us the flexibility to modify the prompts which are used in order to create the graph. In order to create the summaries, even summaries can be tweaked. Like we can tweak the prompt which is used to generate the summary and make it more aligned with the user requirements or the industry requirements that we are focusing on. So in summary, both graph-based methods provide the capability to address high-level and extractive questions effectively. So we looked at both Raptor and GraphRag. Both offer this capability. However, the process of graph creation can be resource intensive. For instance, the GraphRag requires entity and relationship extraction via large language models, followed by summarization, which involves a significantly higher number of LLM calls compared to traditional RAG methods. Similarly, Raptor requires repeated clustering and summarization. So, moreover, so therefore, these are important considerations that we should take into account when selecting between RAG or GraphRag. Similarly, Similarly, graph-based methods demand additional memory to store graph structures. And for certain methods, the response time could also be high. For example, in GraphRag, we saw that in Microsoft's GraphRag, we saw that even at query time, there is this map reduce that works. We first generate partial responses and then combine them to generate the overall responses. So this can add some latency at the time of query. Let's say when user asks a question, it can take longer to generate a response as compared to in case of traditional RAG, where it's comparatively faster. So therefore, when developing a RAG system, it is crucial to consider several factors. The initial step should be to understand the types of queries users are likely to pose. If the majority of queries are extractive in nature, employing a traditional RAG method with advanced search strategies may be a viable option. Enhancing query understanding can also improve performance on high-level questions. For example, if the question is of multi-hop, and what we can do is we can also invest in query processing, where we break a complex question into smaller questions or simpler questions and get retrieval for those, and then maybe it would be easier for the model to reach to the correct answer. However, if the requirements include addressing multi-hop and theme-based questions, let's say for a particular scenario, the majority of questions that will be asked from a RAG system would be theme-based, high-level or multi-hop questions. In that case, it is definitely worth exploring and trying out these different graph-based RAG methods. Among the various graph-based methods, while choosing between them, it is important to evaluate the cost associated with graph creation, storage, and the response time of the algorithm when selecting the most suitable approach. So that is the main takeaway here. So here are the resources to the algorithms discussed in the presentation, including links to the GitHub repo for GraphRag and Raptor. And Yeah, I'm open to questions now. Would love to hear what people think and their experience has been on working on similar technologies.
Yeah, we did have a question pretty early on after the last moment of questions. It came in. You discussed the nodes for the when you build the tree. We got a question if there is metadata associated with those nodes, or are they only the chunks that are in there?
Could you repeat that? If there's metadata associated with the chunks?
With the nodes. So if is there metadata associated to the tree nodes, or are they only the chunks in those nodes where you're building that tree?
So in their original algorithm, there's no mention of metadata, but I think it's very much possible that we can change the structure of the node because it's just a class. We can define it in the way that we can add some metadata, and we can include that in the search strategy. So let's say for the parent node as well, we extract the metadata, and in the search at the retrieval time, we can use metadata as a field to filter down to the right context even further. So
yeah, well, that's a good answer. If we're setting up these graph rack systems, we probably need a solid pipeline. I know it's very easy to do so if you're using Azure AI Search. You just follow the wizard. How hard is it to make this graph rag pipeline?
So without the Azure, if I understand correctly, you're asking without Azure, how hard is it to build the pipeline?
Oh, no, you can include Azure, but I know it's for, as you call it, traditional RAG. It's really easy. People made it really easy to do RAG, but how hard is it to create a pipeline for graph RAG?
So I think, first of all, it is a resource-intensive method, and it takes a lot of time to build the graph rag. In my personal experience, I've seen that for a couple of documents itself, since it does multiple round of gleaning into the corpus to extract entities, and lot of entities are extracted, and after that there are LLM calls for creating the relation between the entities, and then there are LLM calls for summarization and for generating descriptions, and then at the retrieval time as well, there's so many LLM calls. So I think it can take quite some time for it to generate the graph even after sending in a request. So I think complexity lies more on the uh, creation side and also explainability. I think in case of traditional RAG, it's quite simple. When we ask a query, we get the top 5 retrieval. It is easy for us to debug and say that, oh, it did not retrieve the right context in this case. And here the retriever is not doing well, or here the problem is on the generation side. The right context was retrieved, but LLM could not understand it well enough to generate the answer. But in case of GraphRag, debugging the pipeline could be quite challenging because for a given query, the output are community summaries, and then tracking back from the summary to the original chunk that was used to generate the summary could be quite challenging. So explainability, I feel, is like uh, it could be a very big challenge there.
That's true. Yeah, then the metadata could help, of course, if we would have that. But as you said, that's probably expensive as well to figure out. But how would you then handle more dynamic data? So fast changing data, is that something you would combine with traditional RAG? So you have graph RAG for your relationships, and then for the fast changing data, use other mechanisms?
So by fast changing data, you mean that we need to update the index more frequently? Is that right?
Yeah, some data, of course, is really fluent and could change on an hourly, maybe even on a minute basis. You won't be able to update your indexes fast, probably. So how would you deal with that?
Yes, I think updating the index, as you said, would be very challenging in case of a graph rag because the connections would change, the summaries would change, and I think it would be the same for Raptor as well because the parent nodes that are created and the structure is fixed when we update. Let's say bring a new node into the tree, then we'll have to again do all the comparisons, update the summaries, do the clustering, so there's going to be lag there. So in that sense, a traditional rag is way easier, like it's so super simple to add more nodes, update the index. um, yes, so maybe that's why I think we should always have a fallback to the traditional rag because of its simplicity. But graph rag, if there is that requirement that we need such high level questions that need to be answered, or so many multi hop questions, I think query understanding along with traditional rag could be a cheaper alternative. Whereas in case of graph, yes, I think that's ongoing challenge when it comes to updating the index.
Yeah, I can totally understand. And you probably, if you're trying out graph rag, you probably want to benchmark it against the traditional rag. Do you have tips for benchmarking results? What do we have to look for?
So in case of graph rags paper, they haven't presented results in form of benchmark on open source data sets because they said that most of the questions in open source data sets are extractive and not a good benchmark to measure graph rag's high level answering capabilities. And also therefore, in if we read their paper, they have used metrics like um, they have used GPT judge based metric to see how comprehensive the answer is, that is generated by um, their method. So but that doesn't stop us from trying these methods. Like I think in case of Raptor, the benchmarks are available in their paper. They have tried it on Casper narrative QA datasets. um, and I think they've also shown ablation studies on hotpot QA, and they've shown comparison with dense passage retrieval BM25 in terms of accuracy and F1 scores. So those do show us an improvement by using Raptor. So I would encourage people to read those papers to find out a little bit more about those benchmarks. Those can be good starting point, and then they can look at GraphRag. They have blogs as well which Microsoft has provided, and there as well they have shown multiple examples on different data sets showing that this is the output from traditional rag, and here is an output from the graph rag approach. So
Yeah, so it's in the end, it's very much similar in the evaluation as we're doing now with just model comparison. We can of course do this with retrieval mechanisms as well. That's a very good point. And we have another question: which Azure services can be used to store graphs? Well, you probably have a very good answer.
can Azure storage be used to save graphs? Is that right?
Well, all Azure services. So I know, or of course, we can have a Graph SQL database, but does Azure provide other services to store these graphs?
So right now, I think they use Azure Storage and as one resource. Um, but as you mentioned, maybe a SQL based storage can also be used because it's like a structured data that's going to be stored. So yes, but I'm not fully aware of any other service. I think blob storage is the major one.
And I think we have for Gremlin in Cosmos, the Gremlin API for Cosmos DB will probably work as well. So that would be nice
Yeah,
at scale. So I
that's
do hope that answers someone's question. If not, post another comment. And I do have a last question for you, because you touched upon the retrieval latency we could see on query time. So it could take longer, but what is longer? What kind of latency are we talking about? Is that milliseconds something or more seconds?
Actually, it depends on the algorithm. Like in case of Raptor, since there was this approach of collapsing the tree. Once you have collapsed the tree, you're just looking at the cosine similarity at the retrieval, which is very similar to what happens in case of RAG. If you do a vector search, you take the embeddings of the query and then you do a cosine similarity and retrieve the top 5 based on the closest match, and then go ahead and pass that to GPT or a large language model for generating the answer. So in that case, it's very similar to traditional RAG. So the latency is very similar. But whereas in case of graph RAG, if we looked at the retrieval pipeline, in that case, they first find the most similar community summaries. And then based on the most similar community summaries, they generate partial responses. So they have an internal pipeline there. Based on the partial response, they see whether the partial response is relevant with respect to the question. They use that to filter down the search space, and then they use that further to generate the answer. So this can take a while because there are multiple calls involved as compared to a traditional RAG. So I would say it depends on the size of the corpus as well, because if your corpus size is huge, then it's going to take, you will have a large number of community summaries, you'll have large number of partial answers, which you'll have to combine to generate the final answer. So it depends on the size of the corpus.
Of course, yeah, but probably not something a user would want to wait on. So that is definitely something to take into account. And we have another other question from a LinkedIn viewer regarding, and of course you also touched upon this, that the auditing, the how do you call it? I'm struggling for words here. The accountability of such retrieval mechanisms is hard. The question is around that. Would it be a good fit for the financial sector for to track who accessed what within the graph? And you probably already answered it in part, but I did want to answer that question. So, for an audit trail, would it be suitable to view who did what in a graph RAG scenario?
So I think this lies in the fact that if you store the graph on your tenant or like the customer tenant, I think it depends on how secure that is. Because at the output time, we are just going to return the answer. If it's a question answering system, I think we will build an interface where when user sends the question, we get the question, the graph is built on our side, it is stored on us at a secure place. And once we have that question, we retrieve the relevant summaries, generate the answer, and at the end, the user just gets the answer. And if required, maybe the citations to like in case of RAG, we get the most citation to the retrieved chunks. So it depends on the use case. If in case of something which requires, like in case of finance, maybe it's not safe to reveal those, we just reveal the answer. And this is for our purpose as engineers or as data scientists. When we want to debug a pipeline, that's when we look at the retrieved summaries or the chunks to understand why the model could not reach the correct answer. So I think security base, it's just depending on where we're storing the graph, we don't need to expose it to the customers.
Yeah, of course. Yeah, but it's probably not, you're not going to get 100% of what chunks have been used in its process, right? So that would be very hard to do, to get in an audit.
It's difficult to backtrack in case of some algorithms to where did that summary actually come from. And also, it's important to highlight the RAI perspective here, because these models are prone to hallucination or making up facts. So if we rely too much on LLMs in building the graph, that also poses a threat, because what if the model understood a relationship incorrectly, or it generated an incorrect summary? And if the graph is huge, it's a lot of manual tasks to go and check everything, right? If everything is automated, if there's a mistake in one node, it's going to pollute the entire graph, I would say. So there's a considerable amount of risk in that aspect as well.
And that's a very good point, because then we come back to the responsible AI again. For the safety mechanisms, they are still that important to have in place. Yeah. And we have another question, and I'm just going to read it. I've not read it before, so maybe I'm totally messing this up. Can you talk a bit about schema of the graph? How to handle situations where we don't know the diversity of documents that need to be ingested? For instance, user uploaded documents. So
Right. So I think the most basic way to build a graph would be, since it's text data that we deal with, it's like an entity based extraction, which is like, name of a person, organization, name of a place. We have a prompt. I think in GraphRag pipeline there is a prompt which asks, like, given a chunk as an input, it extracts these entities. So these become the nodes in the graph, and then there is a relationship which forms the edge. So basically, like, I gave an example of, let's say, X is the father of Y, so X and Y are the nodes, and father of is the relation. So when it comes to the schema, every node has so it's very similar to a graph structure that you would build in normal computer science, where you have the source, target, and the edge which is connecting. That's how it is. So basically, the collection of those tuplets form the graph structure. And then we have, when they run that hierarchical clustering algorithm on top of it, which is Leiden in this case, then they basically group together different entities together. Basically, they cluster them together, and then they generate summaries of all the all these sets that fall inside a cluster. So, yeah, to answer your question, schema is basically very similar to a set of source, target, and relationship sets inside a list, for example, that can be considered as a graph representation.
yeah, and therefore very flexible, right? Because you can
Hmm.
add relationships and nodes as you wish. So that's
Yes. And even depending on how granular you want the relationship, or how high level you want it, you can tweak the prompts and define it on your own. Even you don't need to have name of a person, place as entities. Depending on the use case, you can tweak them to be completely different things as well.
okay. Very good. I think that was the last question. So thank you so much, Prerna, for sharing. That was very insightful. It was a lovely presentation. And if you have, if any of the viewers still have questions, then they can probably reach out, right? And just find you either on LinkedIn or.
Right.
Oh, sorry.
Yes.
I think
So
you're
for
sharing the
that, I
slide.
have the slide here.
So I was hiding the slides, but I'm showing the slides for where people can find you, or just post them in the comments, and we'll get back to those comments as well. So again, thank you so much, and looking forward to hearing more from you. Thank you.
Thank you. Thank you. Thank you, Roland, and thank